be Mike Cotton.
Hi, I'm here to talk about NTIA's spectrum monitoring project that we're just about to kick off here. We're really excited about the project. We're hoping that it will contribute in all the focus areas that we're going to work on over the course of today. Well, there it goes. So just a quick outline. I wanted to talk about sort of our current mode of operation in terms of how we make spectrum measurements. And then I want to, that's kind of a situation or a system that works for us right now for everything that we look to do. Then I want to talk about sort of catalysts for change and why we're moving in the direction we are with this new project. That came in the form of a budget initiative that didn't get passed in the last budget, but NTIA leadership has decided to put some money towards this project this fiscal year. So ITS's current mode of operation, we've been doing these spectrum measurements for a long time, really since the 1970s, where we started out focusing on federal agencies that were acquiring LMR bands quickly, and people asked us to kind of keep them honest on whether or not they were using them or not. So since the 1970s, we've had this program. It's called the Radio Spectrum Measurement System Program, and we've developed a whole suite of capabilities and hardware setups to basically go out and do broadband spectrum surveys from 100 megahertz up to 20 gigahertz. So we'll load up this van with the measurement equipment that's shown in the upper right-hand corner, and we'll set out and do a band-by-band sweep where detection schemes, antennas, pre-selector designs are all set up optimally for the services that we're measuring each band. Okay, so this is obviously overdone for today's thing, but I just want to mention that this is something that we roll out, and it suits all of our needs. It's big, it's expensive, but we're kind of recognizing that's a little bit overdone. So recently we've been putting more focus on sort of more streamlined systems where we go out and focus on particular bands. Like last year we worked on characterizing the 1.8 gigahertz band. The year before that we made an effort to go out and characterize the 3.6 gigahertz band. And this work, we do a lot of we do have the mathematicians and the physicists to kind of come together and do a lot of the theoretical framework development that needed to be done in these areas, and so we do take a little bit of time. I guess my point is there is a latency, significant latency in our mode of operation now, where we make the measurements, an engineer gets the data, processes it, writes it up, and at a minimum, it's like a 6-month delay for data. So that's one of the big things that we're trying to change with this new project is we're basically trying to automate all that and pump out the data to users on a more shorter timeline. So the catalyst for change, as I mentioned, Tom mentioned this earlier today too, there was a congressional budget initiative from NTIA that made it all the way to the last budget vote and didn't make it in there. It was for 2 years, $7.5 million. But we turned it around. We do have funding this year for $1.5 million. It started 2 weeks ago, so we had 6 months to work that project and make as much progress as we can. Again, we're really excited about that. So one of the things that came out on the budget initiative plan is that we put out an NOI in August, and we got a lot of feedback from panelists here on the table, so it establishes some context. I'm going to just leave this as items on the slide for people to look at, but basically there are objectives to monitor spectrum real time and make that data available, and then basically after 2 years, assess whether or not we want to have that as a long-term plan. So there's going to be kind of a strategic decision-making process about what this project can provide for us. This venue here, I mean, this is a great turnout. I'm really excited to just see what kind of feedback we get from the people in this room. We also had a whole number of collaboration tasks on here. The plan is to allow for other sensors to put data into the database, just like Jesse mentioned, and also have an API in the output so people can take that data and get to it. But we're going to take some care and make sure that, you know, a lot of the sensitive spectrum issues are taken care of, so only authorized people will take a look at that. So the basic development tasks that were put out in the NOI were develop a centralized database, develop prototype sensors to measure particular spectrum bands, and to establish a network of 10 sensors in 10 metropolitan areas to collect data. So that's to be done in about 10 years. In that NOI, really there weren't a lot of specifics, so once we decided to actually pull off this project, we had to kind of make some decisions about how we were going to narrow the scope in order to implement, to get real practical deliverables at the end of this year. Whoops, sorry. So this is the project plan that we came up with. This is how we kind of narrowed the scope. I mean, the first thing, and that's the biggest thing, is that we need to focus on is the quicker output of the data. So we're going to design this database. I should actually take a second too to mention that we have a new collaboration with NIST Information Technology Laboratory, which has been great. I mean, we're very much on the RF side of things. So when we're developing the database, we're really going to lean on these guys to help us out and develop that part of this project with best practices. So it's been a very nice collaboration so far, even though it's only been for a short time. The other significant thing that we need to do is we need to basically replace that $80,000 centerpiece of our measurement system, that's that one single box, with one of these COT sensors that we're going to move next door to take a look at during the break. So for us, you know, we understand that we've been working with the spectrum analyzer for 35 years. We really know that system. We know what the dynamic range is. We know how to move that up and down to measure certain levels, whether it's low levels or high levels. And so we really need to understand and evaluate those boxes. And just for the procurement process, the government procurement process, we need a matrix of capabilities versus cost to say, okay, we need this type of sensor for this application. We need to buy 10 of them. So these 3 are the best. Here's the lowest cost, procure. So that's what we're going to do for our second item. Then we're going to design prototypes this year for radar spectrum and also for LTE. We think that those are going to involve COT sensors from 2 different price points. And so we're going to develop those 2 price point COT sensors into our system. And finally, we're just going to go for end-to-end functionality where the sensor is pushing data to the database and is making available to authorized users. This is basically what it's going to look like. Sensors are out in the field, come in over the IP network, they're ingested into the database and made available to authorized users.
Mike, to wrap up a little bit.
Okay, so we have just initial thoughts. That was for fiscal year 14. I think those were ambitious points. The thoughts for fiscal year 15 are that the 10 sensors that we would like to deploy are sensors to monitor 3.6 gigahertz band along the east and west coasts and the Gulf Coast.